Chapter 15, Number 33. Submarine buoyancy. Submarines adjust their buoyancy by changing the amount of water held in rigid containers called ballast tanks. A. If the mass of a submerged submarine increases while the volume remains the same, does the buoyant force on the submarine increase, decrease, or remain the same? The buoyant force is rho of the water or fluid, whatever it is, times the volume displaced times g. In other words, the weight of the displaced water. So if the volume stays the same and we haven't changed the density of the water it's in, then the buoyant force stays the same. And so the answer for part A, it remains the same. That's part A. Part B, kind of tricky. Calculate the change in the buoyant force on a submerged submarine if it pumps a bunch of seawater into its ballast tank, but the volume has not changed. And, of course, the density of water has not changed. So this is also delta of FB is 0 because those two factors have stayed the same. Now you might wonder, well, why do that? Notice that if we're pumping out air and pumping in water, the mass of the submarine has increased, and therefore the weight is increased, and so it will start to submerge, it'll start to dive. But the buoyant force won't change, so it's changing its weight, essentially.